Okay, here we go. So, according to the official rules of baseball, now it's kind of strange for me to look up here, but I'm trying this whole camera thing. I read it. It's easier for students to understand if they could see me talking, so we're going to give it a try. So I'm looking up at you, my camera's up here above me. All right, so what we're trying to do here is the worst case scenario. So we want to know, according to this outline of how baseballs are supposed to be according to the official rules of baseball, what's the density? And we want it in grams per milliliter. So grams per milliliter means we have to change some things. We have ounces, for example, and we have inches. So I want to do some changes here. Not only that, I need to know that we're talking about a baseball here, so it's spherical. All right, so worst case scenario says I want to find the high density means I need to find the highest mass possible and divide that by the lowest volume possible. So anything I have on the top, I want the highest. Anything I have on the bottom, I want the lowest. That way I'm dividing by the smallest number possible, and I'm multiplying by the largest number possible to get the highest possible density. All right, so to get the lowest possible density, so the low, I need the lowest mass on the top because I'm multiplying by a low number, and then I need to divide that by the highest volume possible. So I have the low mass, the high volume, I have the high mass, I have the low volume, and then that will get me the range once I take the average. So let me just jump in here and do some converting. Let me get rid of what I've done so far, actually. Give me more space. All right, so I'm going to start with this 9.25 inches. So I need to know that the volume of a sphere is 4/3 pi r cubed. And this is saying the circumference is no more than 9.25. So the circumference is equal to, we know the circumference is the outside of the circle. That is 2 pi r. Maybe we know that. Maybe we don't. I'm sure you do. All right, I don't want inches, though, because I want to end up with this thing in milliliters. So I need a plan. Now, the best plan there is to understand, as we did last year, 1 milliliter equals 1 centimeter cubed. So if I can get it in centimeters cubed, the volume I'm talking about in centimeters cubed, then it would be the same as inches, or sorry, milliliters. But I'm right now in inches. So I don't want to use inches, I want to use centimeters. That way I can use centimeters right here for my value for R, and that'll give me centimeters cubed, which is once again the equivalent to milliliters. All right, so once again, converting. 9.25 inches. I need to know the conversion factors. I told you they're in the back of the book. So I was going to grab a book here, but if you flip to the back of your book, you'll see there's a bunch of common conversions. If you're ever missing a conversion, that's the place to go. All right, so we have inches then to centimeters. So 1 inch is 2.54 centimeters. Pretty straight conversion there. Let me grab my calculator. So I have 9.25 and times 2.54, and I got 23 we'll say 23.5 to keep the significant digits at 3 centimeters. All right, so now that tells me then the circumference is 23.5 centimeters equals 2 pi r. So divide that number by 2 divided by pi, 3.14159, or hit your pi button. And then that will give me R. So R equals 3.74 centimeters. All right, now that would be the high version because it says the 9.25 inches is the higher one. I want the lower one as well, so I need to do 9 inches. So I'm just going to follow the same. I'm just going to cross this out right here and just do 9. So 9.00. So I'm going to do the same process. 9.00 times 2.54. That gives me my circumference as 22.86. So I'll plug that in here, divide by 2, divide by, I don't know where pi is on here. I did it. I can't really see it. Pi. All right, so I got 3.64 centimeters for the radius. All right, so for my higher volume, I'm going to use the larger radius. For my lower volume, I'm going to use, obviously, the shorter radius, or the lower, smaller radius. So let's do one of those. So volume equals, so let's say this is the high volume, the high. I got 4/3 pi 3.74 cubed. So 4/3 pi r cubed. For the low volume, 4/3 pi 3.64 cubed. So my high volume, 3.74. I'm use my to the button to the third times high times
all the seniors
4 divided by 3.
Please report to the office at this time. All seniors in Mrs. Irving's home. Thank you.
So 219 centimeters cubed for the high volume. All right, so let's just do the same thing there. So 3.64 to the third times 3.14159 times 4 divided by 3. All right, so we got 2.02 centimeters cubed. Okay, so according to the baseball rules, then, that is the highest and lowest volume that the ball could occupy. I need the masses. The masses are in ounces. I want grams. So I need a conversion to go from ounces to grams. So 5.25 ounces. There are 16 ounces in 1 pound. And in 1 pound, there are 454 grams. Once again, that back of the book reference, you'll find your conversion that you need to get you to grams from ounces. I think they're both there. I should have checked, but anyway. All right, so let's clear that. So we have 5.25 times 1 times 454 divided by 16 divided by 1. So the 149 grams would be the 5.25. So that's the high mass. The high mass. Now we have 5 divided by 16 times 454, and we get 142 grams for the low mass. All right, so now I have all the materials I need to assemble this. The worst case scenario means I've messed up as high as I can and as low as I can on both the volume and the mass. All right, so let me erase here. Give myself some more space. Let me get rid of this. All right, I just messed that up. I need that number right there. So 219 and 202. So now the high density. So the high density is going to be equal to the high mass divided by the low volume. So the high density will be 149 grams divided by, so the high mass. The low volume is 202 centimeters cubed. So 149 divided by 202 gives me 0.738 grams per centimeter cubed. All right, so that is my high volume. Worst case scenario on the high side. Low volume. Low mass divided by the high volume.
Football team and boys varsity golf. You may be excused at this time. Thank you.
0.648 grams per centimeter cubed. All right, so now we're almost there. All we have to do now is find the average of the two and then the plus or minus. So I need to take my high volume, or I'm sorry, my high density, my low density, find the middle. So 0.738 plus 0.648 divided by 2. So it's 0.639. So 693 grams per centimeter cubed, plus or minus whatever it takes to get to the high one, whatever it takes to get to the low one. So 0.738 minus 0.693. So it takes me 0.045 to go up, and you can see it's going to take me the same to go down. So 0.693 minus 0.648. Did I miss that? 6.693, 0.648. So same. So this is going to be final answer, 0.693 grams per centimeter cubed plus or minus 0.045 grams per centimeter cubed. And that makes it all the way to the end.